Hey guys, this is Sakshi and I welcome you all to my tech platform Way to Learn. So we are going to solve PYQs from GATE exam and that too from mathematical physics, and this is my part 5 from 41 question to 50th question. So let us start at 41st question. So we have already completed like around 40 PYQs from GATE. So this will be like the fifth part of this marathon, PYQ marathon. So as soon as we finish these 100 PYQs from GATE mathematical physics, we will be solving classical mechanics. So I hope if you are not ready for classical mechanics, uh, be ready by watching my videos which I have already posted for classical mechanics. You can check my playlist, and and if you have any kind of doubts, you can comment or you can mail. So let us start our first question. So which is from GATE 2009, and this is from complex analysis. So if you see, we have the integral and we also have the contour. So first thing what we have to do is draw the contour. Z is equal to 3 by 2. So as I said, Z is equal to 3 by 2 here. 3 by 2 represents the radius and Z would be the center. So it would be at center with radius 1.5. 3 by 2 is nothing but 1.5. So I assume this to be 1. So this is my contour. Okay. Now let us have our function f of z is equal to e power z divided by z square minus 3z plus 2. So what is the first step? We need to find the pole. So here, in order to find the pole, we put the denominator equal to 0. So z square minus 3z plus 2 is equal to 0. So when you find the roots, you get z minus 2, z minus 1 is equal to 0. So z will be equal to 2 and z will be equal to 1. So if you see, z is equal to 1 lies inside the pole, whereas z is equal to 2 lies outside because our radius is only 1.5. So therefore 2 lies outside 1.5. Hence I can say that 2 lies outside. So I can just find the residue only for z is equal to 1. So in order to find the residue for z is equal to 1, let us find that this is a simple pole, order of 1, right? Pole of order 1. So here we are just going to use the simple pole residue formula. So when we do this, we get e power 1 divided by 1 minus 2 is minus 1. So minus e. So now we have found the residue. The next step will be to find the integral value. So you can use the Cauchy integral value, which is integral f of z dz will be 2 pi I into our residue, which is minus e. Therefore, minus 2 pi I e will be the option. So let us see which option satisfies this answer. So our answer is minus 2 pi I e, which is option C. So let us go for the next question, which is again from counter integral, but a different question. You just have to think what can we do over here. Because if you see, the integral over here is like r cross d theta. So r cross d theta, we can basically write it as r into d theta sine theta. Right. So if you see, for a circle, for a given angle, our radius vector will be okay. So our radius vector and d theta will be at, perpendicular to each other. So therefore I can say that sine theta here, theta will be 90. Therefore I can say r d theta sine 90 which is equal to r integral d theta. So theta varies from 0 to 2 pi in vector calculus. So 0 to 2 pi r, when you do this, you are going to get 2 pi r. Therefore, your integral c r cross d theta will be equal to 2 pi r. Simple question. Just you have to think what can we use over here. So next question is from matrix. A matrix A is given. We have to find the eigenvalues. So basically, I'm going to use the characteristic equation over here. So I have also given some of the tricks to find the characteristic equation in my matrix video. If you find time, please pause this video and check that. And if you find that as a easy problem to solve, like easy trick for you to solve, then you can use that for a 3 by 3 matrix. So it will be very useful for you in order to solve any 3 by 3 matrix. 2 by 2 matrix is basically easy. In case of this matrix, A is equal to 0 I 0. In order to use the in order to use this characteristic equation, I'm just going to use this characteristic equation over here, which is I minus lambda, taking the determinant should be equal to 0. So lambda square minus I square will be equal to 0. So lambda plus I, lambda minus I equal to 0. So lambda will be plus or minus I. So if you see, the eigenvalue is complex and distinct. They are not same. They are not coinciding because one is plus I and another is minus I. So they are complex and distinct. You can place 2 points for each eigenvalue. That is a point for each eigenvalue. Therefore, option B will satisfy. So let us see the next question, fourth question. Which of the following curves gives the solution of the differential equation k dx by dt k2x is equal to k3? So let us solve this differential equation first. K1 dx by dt plus k2x is equal to k3. This was the differential equation given in the question. So we can this first order differential equation. So I am just dividing by k1 on both sides. So here p is k2 by k1 and q is k3 by k1. So in order to solve this differential equation of first order, this is very easy. I have to find the integral factor, just e power integral p dx. So here, if you see, uh, it will be e power integral p dt. So k2 by k1 dt. So I'll get my integral factor as e power k2 by k1 into t. So this will be my integral factor, and I know the solution x is equal to, sorry, x into integral factor will be equal to integral of q into integral factor plus c. So first we are going to find this particular integral. So x into integral factor is e power k2 by k1 into t, which is equal to integral of, this is a constant, k3 by k1 is constant, and this is my integral factor k2 by k1 into t plus c. So I have just included this integration constant at first, so there is no need for you to add again. So let us see this x into e power k2 by k1 into t will be equal to, now when you integrate this, you are going to get k3 by k1 into k1 by k2, sorry, e power k2 by k1 into t plus c. So x e power k2 by k1 into t will be equal to k3 by k2 e power k2 by k1 into t plus c. So now I just need my solution in terms of x. So x should be on one side and all other terms should be on the other side. So I'm going to divide the whole RHS by uh, this exponent term. So x will be equal to k3 by k2 plus c e power minus k2 by k1 into t. So now I can say that this particular k3 by k2 is a constant and I have a constant over here. So let us see if we have any conditions given in order to find this integration constant. Yeah, we have the initial condition x is equal to 0 at t is equal to 0. So let us find this integration constant c, and then I'll let you know the answer which graph suits the answer. So at x is equal to 0, t will be equal to 0. So here x is equal to 0 when t is equal to 0. So this will be c plus k3 by k2. Therefore c will be minus k3 by k2. Right. So when I substitute that c is equal to k3 by k2, I'm going to get my x as, I can remove this k3 by k3 by k2 outside. And I can write this as 1 minus e power minus k2 by k1 into t. So if you plot graph from 0 to like at least for 10 to 15 or some other points, and if you can also remember these sort of graphs for exponential graph or sine graph, tan graph, any kind of graph, like 1 minus e power graph or 1 minus e power 1 by e graph, right? So if you see the option, the only option that suits our solution, that is 1 minus e power minus t. So if you find a graph for 1 minus e power minus t, only option B will satisfy our solution. So this graph satisfies our solution very well, because this is something like 1 minus e power minus t graph. So this into some constant will just enlarge our graph or just decrease or something. It will just add something, but it won't change the entire graphical calculation, or it won't change the entire graph. So therefore this constant will not do anything much. So if you remember graph form, like at least for um main important things, then it would be useful for you to answer any graphical question. For Legender, for Bessel, so this is important for you to know cos, sine, function. So you can learn all those graphs. It will be easy. So now let us solve the fifth question. So consider an anti-symmetric tensor Pij with indices I and j running from 1 to 5, the number of independent component of tensor. So this is an anti-symmetric matrix. So in order to find the anti-symmetric matrix, yeah, number of components. In order to find the number of component of a anti-symmetric tensor, here it is a tensor. It can be a matrix too. So there is nothing much difference. I have already given a formula for you for anti-symmetric and symmetric. So this is an anti-symmetric matrix. So number of components will be half into n square minus n. So here n is 5. Okay. So you can see it is given an equation. So n here is 5. Uh, for a symmetric tensor or symmetric matrix, if you have to find the number of independent components, then the formula will be half into n square plus n. The only difference is that plus and minus. So here for n, on substituting that, you get 25 minus 5, which is 20 by 2, which is 10. So the number of independent component of a tensor or a matrix will be, can be found by using this formula, and it is 10, option B. So let us see next sixth question. A very easy question here. The value of the integral e power z sine z by z square dz, where the contour c is the unit circle. So unit circle represents circle of radius 1. But here if you see, our center, z minus center is equal to radius. So this was the formula I have already given. So here center is 2. Therefore I can write this 2 comma 0 as my center. This will be my center. So this will be 2. Then therefore for unit circle it will cover 1 and it will cover 3. This is my unit circle. Now let us write our function f of z dz is equal to e power z sin z by z square dz. So if you see, we have to find the denominator, the pole, by equating the denominator to 0. So z square will be equal to 0, z is equal to 0 is the pole. So if you see z is equal to 0 lies outside. So when z is equal to 0 lies outside, then you don't have to find the residue. The direct answer will be 0. So the value of this integral e power z sin z by z square dz will be equal to 0. A very simple question. So let us see the seventh question from Laplace transform. Here, if you don't know any important identities or properties of Laplace transform, the only thing that you have to remember is the formula of Laplace transform. How to find any Laplace transform. The first basic definition of Laplace transform. If you remember that, that will be very much easy for you to answer these questions. So we have to find the Laplace transform of any given function. Then the property is given as 0 to infinity e power minus sx f of x dx. This will be the function. Now if you see our function given in the question, so f of x is 0 from 0 to 3, and then it is x minus 3 from 3 to infinity. Okay, so I can write my function as from 0 to 3 it will be, the function will be 0. Therefore, this whole entire function will go to 0. And from 3 to infinity, my function will be e power minus sx, x minus 3 dx. So now I have to just integrate this particular integral. So I can use this as u and this as v. So integral u dv will be uv minus integral v du. So u is nothing but x minus 3 and du will be 1. And v is nothing but e power minus x. Sorry, dv is e power minus x sx. Therefore, v will be e power minus sx divided by minus s. Okay, so now let us solve this particular integral. L into f of x will be uv. uv is x minus 3 into e power minus sx by minus s from 3 to infinity minus integral v du. So v is again e power minus sx by minus s into du is nothing but 1. So dx 1. Okay, dx. Yeah. So this is from 3 to infinity. So this integral, this part will again go to 0. So now we have to integrate this. Minus and minus will give us positive answer. So it will be e power on integrating this particular function, we get e power minus sx divided by s square minus s square 3 to infinity. So now when you apply the limits, first part will go to 0, e power minus sx by s square. So this infinity, this will go to 0. This will be minus e power minus sx by minus s square. This will be 3. Okay, so now you know that the Laplace transform for this particular function will be minus and minus will give us a positive value. So s power minus 2 e power minus 3s. So this is our answer, which is option D. So let us see the eighth question. This is from differential equation. A very easy differential equation, but a time taking one. We can easily do this differential equation, and this is a second order differential equation. So let us write this d square y by dt square minus y is equal to 2 cos h t. Right. So I can write this as d square minus 1 into y is equal to 2 cos h t. So first I have to find my complementary function, then I am going to find my particular integral. So here if you see, I am just replacing this 2 cos ht by e power t plus e power minus t. Okay, so this will be a basic substitution instead of cos ht. Yeah, instead of 2 cos ht. So e power t minus e power minus t is a basic substitution for 2 cos ht. So now I'm going to find my CF. So CF m square minus 1 is equal to 0. So m will be equal to plus or minus 1. So these are real and distinct values. Therefore, my complementary function will be CF is equal to a e power t plus b e power minus t. This is my complementary function value. Now I have to find the particular integral. So particular integral, I'm going to find particular integral of e power t and e power minus t. So particular integral of e power t will be equal to 1 divided by d square minus 1 e power t. So now when I substitute 1 over here, this will become 0. So I'm going to do the second step, which is differentiation. So I'm going to write this as t 1 by 2d e power t, which will give me t by 2 into e power t. So now particular integral of e power minus t will be again the same thing, 1 by d square minus 1 e power minus t. So again it will go to 0. So I'm going to write t 1 divided by 2d minus e power minus t. Yeah. So 1 divided by 2d is equal to 1 minus e power minus t, which will be minus t by 2 e power minus t. So this is my particular integral for e power t and e power minus t. So now I'm going to write my entire integral solution. Y is equal to CF plus PI. So y will be equal to a e power t plus b e power minus t plus t by 2 e power t minus e power minus t. So this is similar to sin ht. So my final solution will be a e power t plus b e power minus t plus t sin ht. So this will be my solution. Now, if you see the question, you can see that the initial condition is given as y of 0 is equal to 0 and y prime of 0 is equal to 0. So let us write the initial condition. Initial condition here is y of 0 is equal to 0 and y prime of 0 is also equal to 0. So for y of 0 is equal to 0, we get 0, a e power 0 is 0 plus b e power 0 is 0 plus 0. So a plus b here is equal to 0. So a is equal to minus b. Okay. So now we have to find y prime. So y prime here will be a e power t. So when you differentiate this, you get minus b e power minus t. Now we have to differentiate this. So I'm going to differentiate t once, then t cos ht. So y prime of 0, y prime will be 0 when t is equal to 0. This will be a minus b plus sine ht. Uh, Sine ht will be at t is equal to 0, sine will be 0 plus this will be t. At t is equal to 0, okay, this entire term will go to 0. This will also go to 0. So you have a is equal to b here. So let us see the initial conditions once again. Here is a small mistake. I think, yeah, okay. So we have done y of 0 is equal to 0. So which will give us a plus b is equal to 0, and a e power 0 is 0, and e power 0 is b. A plus b will be 0. And then for y prime, we are going to do the same. Yeah, here if you see, a minus b is equal to 0. But we know that a is equal to minus b. So therefore, minus 2b will be equal to 0. Therefore, b will be equal to 0. When b is equal to 0, then a will also be 0. So you're just substituting this a is equal to minus b over here. So after doing that, you get a and b to be 0. Therefore, your answer, the final answer, after substituting the initial conditions and after finding out the constants, you're going to get y is equal to t sine ht. So this is nothing but option D. So t sine ht is the option D. So I hope you get this solution. You can try this out by yourself. So let us see the next question, which is the ninth question. This is a time-taking question, but you can try solving this. I'm going to solve only one option, and the rest options are your homework. So you're going to try those options and see if you're going to get the right answer or not. So let us see. If you see here, we have to find which of the following integrals has non-zero value. So we have to find the non-zero value. So non-zero value basically we have to see which option is not equal to 0. So I'm going to choose one particular option, the correct option, and I'm going to solve that. You're going to use the same method to solve the other option, and we have to check if you're getting the answer as 0 or not. So you're going to do that. So let me solve this. First, I'm taking my option A as the answer. So it is given as minus 1 to plus 1 x square pn of x pn plus 1 of x dx. So now I'm going to write this particular integral as minus 1 to plus 1 x pn of x into x pn plus 1 of x dx. So if you see this, I'm just uh, removing this x square as x for pn of x and the other x for pn plus 1 of x, so that I can use this particular recurrence relation over here. So from this I can find, from this given recurrence relation I can find x pn of x. So now I'm going to substitute my integral for x pn of x, which will be n plus 1 by 2n plus 1 pn plus 1 of x plus n divided by 2n plus 1 t n minus 1 of x. Be careful while doing these process these calculations. So sometimes you might just make a simple mistake and find the option to be wrong. So let us see this how to solve. So n plus 1, I have found this x p n of x. Now my next thing is multiply this whole thing by x p n plus 1 of x. So now if you see this is x p n of x, now I have to write x p n plus 1. So I'm going to replace every n in this relation by n plus 1. So I'm going to replace this n by n plus 1. So therefore this will become n plus 1, this will become n plus 1, this will also become n plus 1, this will also become n plus 1, this will become n plus 1. So I hope you understand this step over here. So while doing that, I will be yeah, I'll be getting n plus, okay, here while doing that I'll be getting n plus 1. Okay, if you see here I have done a small mistake. This will be n plus 2, this will be n plus 1. So I'm going to choose my option A as the correct answer. So therefore this will be n plus 2, this will be n plus 2. The process is the same. I'm just replacing my n plus 1 by n plus 2 because now my option is changed, so I'll be having n plus 2 over here. So this is n plus 2 over here. So on doing that I get my answer as n plus 3 divided by 2n plus 5 pn plus 3 of x plus n divided, okay, this is n plus 2 divided by 2n plus 5 pn plus 1 of x dx. So I hope you understand this. I have just replaced my n plus 1 by n plus 2. Okay, so option A will be the right answer. You are going to do it for option B, option C, and option D. The same process. So now I am just going to multiply this normal multiplication over here. So minus 1 to plus 1, n plus 1 into n plus 3 divided by 2n plus 1 into 2n plus 5 pn plus 1 of x into pn plus 3 of x. Similarly, n plus 1 into n plus 2 divided by 2n plus 1, 2n plus 5 pn plus 1 of x into pn plus 1 of x plus n into n plus 3 divided by 2n plus 1, 2n plus 5 pn minus 1 of x pn plus 3 of x plus n into n plus 2 divided by 2n plus 5 2n plus 1 pn minus 1 of x pn plus 1 of x. So if you use the orthonormal property, the whole bracket over here, this will be dx. So if you use the orthonormal property of this particular Legendre polynomial, this is from Legendre polynomial, right, as given in the question. So we can use the orthonormal property here. I'm going to write the orthonormal property over here, which is minus 1 to plus 1 pm of x pn of x dx will be equal to 2 divided by 2n plus 1 delta mn. So if you see, when m is is equal to n, delta mn will be equal to 1. When m is not equal to 1, delta mn will be equal to 0. So now using this particular property, this is orthonormal property. So using this particular property, one can solve this particular huge equation very easily. Okay, so if you see here, only when m and n are same, your RHS will be equal to 1. Otherwise, your RHS will be equal to 0. Okay, when m is not equal to n, your RHS will be equal to 0. So now if you see this, the first term, here this will be your m, this will be your n. N plus 1 and n plus 3 are not equal, hence this term will go to 0. And if you see here, n plus 1, n plus 1. Therefore, they are equal, so this term will be equal to 1. That is, delta mn will be equal to 1 over here. Okay. And then, this term will go to 0. Again, because this is n minus 1, this is n plus 3, they are not equal. Here, n minus 1 and n plus 1, they are not equal. So, this will be 0. So, therefore, you can use this particular important property of Legendre polynomial to solve this question. So now I can write that minus 1 to plus 1 x square Pn of x, Pn plus 2 of x will have some value which will be equal to 2 by 2n plus 1. 2 by 2n plus 1 into 2n plus 1, 2n plus 5 divided by n plus 1 into n plus 2. When you simplify this further, you are going to get this particular thing. So you are going to get 2 into 2n plus 5 divided by n plus 1 into n plus 2. So this is not equal to 0. Therefore, you can see this is not equal to 0. Even if you put n is equal to 0, you're not going to get any non-zero value. Okay, you're not going to get any zero value here. So therefore, this option suits the given question. So option A will satisfy. So you're going to try the same for option B and option C and option D. So you're going to check whether you're getting 0 or not. So let us see the last question over here, which is from yeah, Gate 2011. A vector from vector and very simple question. The unit vector normal to the surface at the point. So whenever you have to find a unit vector normal, you are going to take del phi. Okay. Now you have phi as x square plus y square minus z minus 1. So now unit vector normal at a given point. So you're going to find del phi. Just remember unit vector normal, then del phi. Okay. So del phi, you're going to get 2x I cap plus 2y j cap minus k cap. Okay. And then unit vector normal will be n cap is equal to del phi divided by. Okay, this will be your unit vector normal to this particular surface at a given point. At a given point P. So del phi at point P will be at point 1 comma 1 comma 1 will be nothing but 2 I cap plus 2 j cap minus k cap. And now on taking the magnitude of this particular del phi term, you're going to get 4 plus 4 plus 1, which is root 9, 3. So now your unit vector normal to this particular surface will be 2i plus 2j minus k cap by 3, which is option D. So we have completed like 50 PYQs from GATE Mathematical Physics. So stay tuned for more videos, and I hope you like these videos and you're solving together. So also wait for many PYQ videos and videos on new subjects too. So share my videos, and if you haven't subscribed my channel, please subscribe. So see you in my next video. So ta-da! Also share all these videos with your friends and learn together. So see you in my next video.